Hello. I'd like to do part 2 of chapter 7, basically on mobile, but a little bit more on the wireless before we do that. Technically, we talk of 5 generations of technology in the 40 years that we've been talking about wireless. 1G started in 1980, was voice only, analog, small areas, 1 transceiver each. 2G came along 11 years later in 1991. It used digital, and by the methods that it compressed items, it was able to have carry more. And but it had more errors, because digital goes on and off, and that produced some errors. 3G started in Japan in 2001 and South Korea in 2002. It has a high bandwidth, and its job is internet access. Now 4G, in 2009, network mobile broadband exceeded voice for the first time. 4G is all IP, internet protocol, including IP for voice, which 3G does not do. It uses a standard called long-term evolution, or LTE. You can look that up in the textbook. I'm not going to go through it in detail. Now we're talking about 5G. What 5G does is change the bandwidths it uses. It goes high up into the gigahertz. And if the bandwidth is high, then the frequencies are the opposite. So with these frequencies are directional. They don't scatter out everywhere. They beam in on a place. That makes it so that each of the antennas can carry, be small, and then more of them can be put on one tower. 5G can be 20 times faster than 4G. So that gives you a little bit about the terminology, the jargon you will hear. From what I've been seeing on the net, nobody is convinced that there's a pure 5G network floating around, or at least there wasn't at one point. Now, mobility. Just because a network is wireless doesn't mean it's mobile. You can have a wireless node that stays where it is, and you can't move it. You can't move any of the wireless on the network. Mobility means that you can take your host and move it somewhere else. And the problem here is you have a host that's wandering. That means it's no longer in its home area. And now, how do you get to it? Because its address you get to by going to its home area. But it's not there. So, approach 1 is to have the visiting host give its IP address to the routers in its new area, and those routers will get messages to it. We use a correspondence method. First, the roving host notifies the mobility manager of the cell it is visiting. That's just a node, possibly the gateway node. And it says, I'm here. It gives its IP. The mobility manager then, of that cell being visited, then sends a message to the home cell, to the gateway or the mobility manager of the home cell, that the host is in its cell. The node calling the roaming host, excuse me, The node calling the roaming host, one approach is it sends a message to the roamer's home cell's gateway, and that gateway forwards it to the visited cell's gateway. Now that's one possibility. Method 2, the node calling I want to get rid of this one. The node calling the roaming host sends a message to the gateway of the home cell of the roamer, and that gateway does not transfer it over. It tells the calling node where the roamer is, and then the calling node, the caller, has to send to that gateway. So that's basically the few things I want to say about the wireless. There's lots of detail in the book if you want to go into it, but I don't think we really want to at this point. See you later. Bye.